found some carboxylic acid. Carboxylic C acids. Just call them C acids. Just do that. Right, they got a functional group COOH. That means they got a little bit on the end with a C, then a double line and an O, and then a single line, and then a OH. Oh, that actually works. Oh, so proud. Anyway, right. Their names end in anoic acid and start with the normal meth, eth, or prop. Okay, so you can have propanoic acid, ethanoic acid, methanoic acid. That's basic. Alright, so you just need to know that they have the COO end bit on the end of them, and they are... Wait, which way am I going? Oh, I don't know. Anyway, and they have anoic acid... Anoic acid... no, anoic acid on the end of them. Right. Carboxylic acids react like other acids. They react like other acids to form carbonates, which produce carbon dioxide. Okay, so say you had ethanoic acid, because that's the example down here, and sodium carbonate, you'd get carbon dioxide and sodium ethanoate. Because the salts formed in these reactions end in anoate, e.g. methanoic acid will form a methanoate, e.g. ethanoic acid form an ethanoate, etc. Like, I'm assuming propanoic acid will form a prepanoate. Maybe. Hopefully. Anyway. Good, so far we've got that they end in COOH, and they react like normal acids when they react with sodium carbonate and other carbonate salts. Anyway, focus. Right, ethanoic acid plus sodium carbonate goes to carbon dioxide and sodium ethanoate. Okay, so say it was ethanoic acid and barium carbonate. I don't even know if that exists, but it's an element, so I'm putting it in just for purposes of examples. You'd get carbon dioxide and barium ethanoate. Yeah, I think. Yeah, no, that makes sense. Okay. So, carboxylic acids, or C acids, or carbolic acids, dissolve in water to produce acidic solutions. When they dissolve, they ionize and release H+ ions, which are responsible for making the solution acidic. Okay, so they release hydrogen ions, which makes its solution acidic, because they're positive, and that's what they do, possibly. Anyway, so... Although, I can compare here. Cheeky. No, right. I know that because of the last video. Ethanol reacts with water to form neutral solutions. However, wait, is it just ethanol? No, all the first three alcohols all dissolve completely in water to form neutral solutions. Okay. But these ones dissolve in water to produce acidic solutions, which makes sense because they're acids. And if you put an acid in something that's neutral, you're gonna get something that's acidic. I can kind of get that. That kind of makes sense to me. Right, but because they don't ionize completely, not many H+ ions are released, they just form weak acidic solutions. That means they have a higher pH than aqueous solutions of strong acids with the same concentration. Okay, so they are less acidic than strong acids with the same concentration. Okay, so concentration and strength is different. You can have the same concentration of something, but it'll still be different strength. Like, say, squash. I can use squash in this example. Cheeky. I keep saying that today, I don't know why. Anyway, right, so if you had a really, really strong squash, like bottle of squash, that was like, Robinson's double concentrate, hey? Right, Robinson's double concentrate, and then you had your Robinson's single concentrate. If you put the same amount of them into two different glasses of water, there would still be the same concentration of squash in both things. Like, there'd still be the same amount of squash to water ratio in both of them, but because the stronger one was poured in, no, because of that, it's more strong. So you'd get a stronger glass of squash, and so you'd probably hate it and have to pour it away. But anyway, irrelevant. So strength and concentration are very different things, and therefore, linking it back to this thing here, yeah. They dissolve in water to produce acidic solution. When they dissolve, they release ionize, right? But although they don't ionize completely, and so although you could have the same concentration of one of these ones and a normal acid, the normal acid, like that's because it's gone backwards, so I'm not sure which way is which. The normal acid would produce a stronger solution than the carboxylic acid, because the normal acid ionizes completely and the carboxylic acid doesn't. If that makes sense? No? Maybe? Who knows? Just keep repeating this video if it doesn't, until it does. Anyway, some carbolic acids are fairly common. Ethanoic acid can be made by oxidizing ethanol. Microbes like yeast cause the ethanol to ferment. Ethanol can also be oxidized using oxidizing agents. Okay, so ethanoic acid. Ethanoic acid, that's one of the carboxylic acids because it ends in anoic, which we discussed earlier, and it was and so it's just a way of making carboxylic acids. The example it gives here is ethanol plus oxygen, so when it ferments in air, and aerobic fermentation, gives ethanoic acid and water. Ethanoic acid can then be dissolved in water to make vinegar, which is used for flavouring and preserving foods. So basically, I'm assuming here, just assuming, if you had some ethanol, just a pot of ethanol, and you opened a lid and you just left it there, it would form ethanoic acid and water. But in the next point, it tells me that ethanoic acid can then be dissolved in water to make vinegar. So, if I had a pot of ethanol and I opened the lid and I left it there for a bit, would it turn into vinegar, which I could then use on chips like a week later or something? It's the thing they don't tell you in these books. It's just not good enough. Anyway, citric acid, another carbolic acid, is present in oranges and lemons and is manufactured in great quantities to make fizzy drinks. It's also used to get rid of scale. See page 78. Oh, I don't want to do that. You don't want that either. I'll just do that in a different video. So, citric acid is present in oranges and lemon. Okay, so citric acid is just like a really, like, it must just be the nice sweet thing that if you drink too much it just gets weird. I believe I'm doing this right. Carboxylic acids are used in industry to make soaps and esters. Carboxylic acid with longer chains of carbon atoms are used to make soaps and detergents. Okay. Carboxylic acid is also used in the preparation of esters, which I'll go through in the next video. And ethanoic acid is a very good solvent for many organic molecules, but ethanoic acid isn't usually used as a solvent because it makes the solution acidic. Okay. Right, so longer chains carboxylic acid, so not your ethanol, your methanol, your propanol, because they're really short chains, because they just are. If you don't know that by now, good luck. So yeah, so ones with longer chains are used to make soaps and detergents. I'm not sure what a detergent is. I know what soap is, obviously. I mean, I wash, but I don't know what detergents are. They're like washing machine stuff. I don't know, I'll find out. Anyway, not really important, I don't know they're going to ask you what a detergent is. And if they do, just say long chain carboxylic acid. Boom. 8 marks. Probably not 8 marks. Probably 1 mark. But yeah, you get some marks. Because of me. Broke face. Anyway. Carboxylic acid is used in the preparation of esters. Esters. Okay, esters are... What are esters? Esters are awful. Esters are when you react to carboxylic acid and an alcohol, which this video and last video was sort of talked about, and you combine them and you get an ester, but I'll go through more of that next video. And ethanoic acid is a good solvent for many organic molecules, but ethanoic acid isn't usually chosen as a solvent because it makes the solution acidic, because as we discussed earlier, when you put ethanoic acid into water, it makes the solution acidic, but not as acidic as the same concentration of a normal acid, because they ionize completely and carboxylic acids don't ionize completely. Bang! Feeling like a boss right now. Okay, so quick overview. Right, overview. The names end in anoic acid. They have the functional group COOH. They react like other acids, but they are not as strong as other acids with the same concentration because they don't ionize completely. They react with sodium, no, not with sodium, they react with carbonates to form anoates. They form anoates. For example, ethanoic acid, and anoic is the acid end bit. That's my confusion, my bad. So for example, an ethanoic acid plus sodium carbonate gets you to carbon dioxide and sodium ethanoate. And they dissolve in water to produce acidic solutions, but they don't get as strong as normal ones because they don't ionize completely, but we've been over that. Oh, I've got a little flick thing. Wait, no, there it is. See? It's just I can't tell which way it is. If you leave a pot of ethanol out, I'm sure it can turn into vinegar, because ethanol plus oxygen, when it oxidizes aerobically, leads to ethanoic acid and water, and that's how you produce a carboxylic acid. Oh, it's that same flick, Jesus. And it can then be dissolved in water to make vinegar, which is used for flavouring and preserving food. Citric acid is also there. Long chains, okay, so what else are they used for in industry? They are used, long chain ones are used to make soaps and detergents. They're used for the preparation of esters. They're also a very good thing for solvent for many organic molecules, but it's not usually chosen because it makes the solution acidic, because when you put it in water it makes it acidic, but not as acidic as normal acids, because it doesn't ionize completely. Boom.